Alright, we are going to check to see if an ordered pair is a solution to an equation. Alright, so here's my equation, my first one we're going to look at. We're going to say y equals negative 7x minus 3. And I want you to notice there's two variables. There's an x and there's a y. So when I get my answer, it's going to come in this form, an ordered pair where there's an x and there's a y. In other words, my answer is a point on a graph. Okay? If I got an answer of, I don't know, 2, 5, that would mean that I would start at the origin, go right 2, up 5, and I'd put a little point at 2, 5 on the graph. That would be the solution, or one of the solutions to my equation. Now, these equations with an x and a y with two variables, I have the hiccups, there are infinitely many solutions, because if we were to graph all the points that were solutions, they would make a straight line, and every point on that line would be a solution. Okay? Alright, so we're going to take a look here. I'm going to give you a potential solution, and we're going to see if it indeed is a solution. So here's our equation. Here's our potential solution, negative 425. We want to see if that actually works. Alright, so the first thing that I do when I have a problem like this is I label my point, right over top. Label my point x, y, x comma y. Alright, second thing I do is I take, and in place of my y, I'm going to put in the 25 in parentheses from my ordered pair. And I'm going to put my negative 4 in for x in parentheses. Anytime you put a number or some kind of expression in for a variable, substitute it in, you have to put parentheses around it. Alright, so that's my first step. And from here I just simplify both sides of the equation. The left side doesn't need simplified, it's only a number. So I can get rid of the parentheses there. On the right side, I have the choice between multiplying negative 7 times negative 4 or subtracting 3 from negative 4. So this is where my good old please excuse my dear Aunt Sally, the order of operations, PEMDAS, as some people like to call it. See that multiplication comes before subtraction, which is down there, right? This one right here. Okay, so I need to multiply first. So negative 7 times negative 4 is 28, positive, right? I still have minus 3. And I'm going to keep simplifying. The left isn't going to change, it's just 25. And on the right I have 28 minus 3, which is 25. And guess what? This works because the left and the right side are equal to each other. Check mark, it works. Okay, so what that tells me is that negative 4 comma 25, that ordered pair right there, when I subbed it in, it worked. So that's a solution. So actually what I'd like you to write, I got a little premature there. I want you to write the ordered pair is a solution, and then you can circle it. Doink. There it is right there. Okay, let's try another one. Let's see. Let's go with y equals negative 9x plus 4. That's our equation. This is our potential solution. Let's go with 5, negative 41. Let's see if it works. So, label my point x, y. Always do that. Might seem silly, but it takes a second, so just do it anyways. Alright. Y is negative 41. I fill it in. X is 5. If I label my points, I'm not going to make a mistake. I know what x is and what y is. I have to add 4. And I'm going to split my equation in half. Okay? The left side, well, that's pretty simple. That's just negative 41. The right side, I have to multiply before I add. Please excuse my dear Aunt Sally again. So that's negative 45 plus 4. Put my equal sign there, right? Left side stays. This side over here, negative 45 plus 4, they're different signs. So I'm going to subtract. 5 take away 4 is 1. Borrow there. So I get, that's stupid. I didn't have to borrow. Let me go back. What am I thinking? Borrowing. Alright, 5 take away 4 is 1, and there's a 4 left. So we get 41. And since there were more negatives than positives, we're going to make it negative. And look, we see that the left and the right side are equal again. Check mark. It works. So I'm going to write 5, negative 41, that's our original point, is a solution. Don't get lazy on me. Write what I just wrote. If I did it, you can do it. It's fun. All the cool kids are doing it. Alright, let's look at another one here. What color do I want to use? We'll make it blue. Why not? Alright, let's see here. Our equation, we're going to do some fractions here in a minute, not quite yet, is y equals 12x minus 16. Possible answer, negative 6, comma 88. Alright, we're going with purple. I like purple. Label your point. Do that first. 88 goes in for y. Negative 6 goes in for x. We're set up, ready to go. Okay, this line that I've been drawing in here, that's not actually necessary. I'm just showing you there's a left side and a right side. Okay, alright, so the left side is 88 equals, please excuse my dear Aunt Sally, you want to multiply. That is negative, what is that, negative 72 minus 16. So we have 88 equals, they're both negative, so I have to add them and keep the sign. If I add, do this off to the side here, scratch work, 6 and 2 is 8, 7 and 1 is 8. I add, but I have to keep that negative sign too, add and keep the sign. That is not true. They look the same, but one's positive and one's negative, so I put a slash because they're not equal to. And so this is the first possible solution that didn't work. When I write my answer, I say that the ordered pair, negative 6, 88, is not a solution. That doesn't mean there are no solutions. That means that this one that we tried didn't happen to be one of them. There are actually infinitely many solutions to this equation because each solution is a point on the line, and there are infinitely many points on a line. That's crazy stuff right there. Alright, let's see here. We'll do one more. We'll put a fraction in the mix. Now if you're using a calculator, that's good because it'll take care of the fractions for you and make them less scary. But if you don't have a calculator, you'll have to do it the way I'm doing it right here. So here's my equation. Our possible solution is going to be negative 12, 21. We're going to check to see if it actually works though. Like a good student, I label my x and my y because it doesn't take long and it saves headaches, so you do it. And we'll use blue here. Alright, 21 goes in for y. How do I know that? Well, it's because I labeled my point. Equals negative 5 over 6. My x is negative 12. Alright, I'm set up to go. I'm going to split this baby in half. There we go, split it in half. Alright, let's see the left side. It's pretty boring. It stays the same. This side over here, oh my, I'm going to do this scratch work. I have negative 5 over 6 times negative 12. It's in parentheses in my equation, but I'm getting rid of it. I'm going to put it over 1. Still negative 12 if I do that. That's legal. I'm going to see if I can cross cancel. I can divide 6 by 6 to get 1. Negative 12 divided by 6 is negative 2. And that gives me 10 because negative 5 times negative 2 is 10. If I wanted, I could put a 1 underneath there, but that's just 10, so why put the 1? Alright, so that becomes 10 plus 11. Okay, well, left side's boring, it's done. Right side, 10 and 11 add up to 21. That looks like a true statement to me. What's that mean? Well, that means that negative 12, comma 21 Why did I do that again? Got ahead of myself. Negative 12 comma 21 is a solution. Done.